Collinearity are two vectors or 3 points collinear if two different vectors drawn between those points are equal or parallel, then the points are collinear. The way they've got it shown here is that the B is the common point, but it doesn't have to be. It could be AB parallel to AC. That would be sufficient. Or let's see, AC parallel to BC. That would be sufficient to show collinear points as well. There has to be a common point, and the vectors have to be parallel, and then the 3 points are collinear. Okay, example 9. Prove that the points A, B, and C are not collinear. So what we have to show, for example, is that AB is not a scalar multiple of, let's say, BC, not. Okay, so let's do AB. We have -3 plus 1 and 2. BC. We have 1, 1, and 0. So let's just see. Let's try this out. For the x component, right, from AB, we have -3 lambda to get a 1. So here lambda would have to be equal to -3. For the y component from AB, we have 1 lambda and 1. And from this, we would think lambda is equal to 1. We don't have to go any further than that. We could check the z component. But because this is inconsistent, there exists no lambda that will make AB equal to BC. So AB is not parallel to BC, and A, B, and C are not collinear. Not collinear. All right. Linear dependency. Next box. A, B, and C are linearly dependent if exists lambda and mu such that C is lambda A plus mu B. That means some combination of multiples of A and B can be combined through a linear addition process of the vectors using the scalar multiples lambda and mu to reach that. Okay. Then those vectors are actually coplanar as well, right? That's what they're trying to say here, coplanar. And there'll be an extension on the note explaining what coplanar is. Okay, so if you can find a lambda and mu that will make that true, then the 3 vectors are in the same plane and they are coplanar, they're linearly dependent. Prove that the vectors A, B, and C are linearly dependent. Okay, so I need to find a lambda and a mu that'll make C equal to lambda A plus mu B. Now, C is -7, 6, -7. A is -1, 2, and -3. And B is 2, 0, -1. I'll break this down by components. That's the first step, and then we'll probably be out of time for this video. For the x, we have -7 equals -lambda plus 2 mu. 6 is equal to 2 lambda plus 0, 0 mu, and -7, -3 lambda minus mu. Now we have to solve this for lambda and mu, and there can only be one solution, and it has to work for lambda and mu for all 3 equations. That's the next step.